The question we are solving now belongs to test series 9. It is of signals and system subject. In specific, it belongs to jet transforms. As per the question, there is a discrete time signal x of n whose jet transform is given as x of z is equal to e power minus 2 multiplied by 2z minus 2 e power minus 2 whole multiplied by z divided by z minus e power minus 2 multiplied by z minus 2. The ROC of the same is given as mod z greater than 2. We need to find x of n from the given data. So from the given data, x of z can be simplified as e power minus 2 whole multiplied by z inverse divided by 1 minus e power minus 2 z inverse multiplied by 1 minus 2 z inverse. This is by taking z in common both in numerator and denominator. Now this can be split into partial fractions as e power minus 2 z inverse divided by 1 minus e power minus 2 z inverse minus 2 z inverse divided by 1 minus 2 z inverse. The ROC of this x of z is given as mod z greater than 2. Now we need to find the ROCs of individual terms. We know that ROC is bounded by poles and shouldn't contain any poles. Hence, the first term has ROCs as mod z greater than e power minus 2 and mod z less than e power minus 2. The second term has the ROCs as mod z greater than 2 and mod z less than 2. Now, we need to pick the ROC combination from these two sets such that intersection of the ROCs is at least mod z greater than 2. So from this we see that the ROCs of each of the terms can be picked as mod z greater than e power minus 2 and mod z greater than 2. We know that z transform of a power n u of n is equal to a power n u of n is equal to 1 by 1 minus a z inverse with ROC as mod z greater than mod a. From this data we can say that the z transform of first term is equal to, or the z transform of 1 by 1 minus e power minus 2 z inverse is equal to e power minus 2 whole power n u of n. Please note that here we have considered the ROC as mod z greater than e power minus 2. From this data we can say that z transform of z inverse divided by 1 minus e power minus 2 z inverse is equal to e power minus 2 whole power n minus 1 u of n minus 1, because the z inverse corresponds to the delay unit and multiplying by z inverse is equal to delaying the signal by 1 unit, because of which the signal gets simplified as e power minus 2 whole power n minus 1 u of n minus 1. From this we see that x of n can be finally written as e power minus 2 multiplied by e power minus 2 whole power n minus 1 u of n minus 1 minus, for the second term similarly we can write that 2 multiplied by 2 power n minus 1 u of n minus 1. This can finally be simplified as e power minus 2 whole power n u of n minus 1 minus 2 power n multiplied by u of n minus 1. For the given x of z with the given ROC, we finally got the x of n as shown. Hence, the correct option is A.